DSPy employs declarative signatures to encapsulate input-output behavior for language model tasks, enabling modular and optimized prompt generation. This artifact demonstrates the framework's citation-enabled document handling through a custom signature that processes structured documents and returns answers with source references. We'll examine how the AnswerWithSources signature is defined with document and citation types, how documents are instantiated with metadata, and how the predictor module executes the task using a specified language model. The code reveals DSPy's approach to integrating citation capabilities with standard prediction workflows.
Import DSPy. From DSPy, signatures import signature. From DSPy, experimental import document citations. Class AnswerWithSources signature. Answer questions using provided documents with citations. Documents, list document equals DSPy, input field. Question, SDR equals DSPy, input field. Answer, SDR equals DSPy, output field. Citations, citations equals DSPy, output field. Hash create documents. Docs, document. Data equals, the Earth orbits the Sun in an elliptical path. Title equals, basic astronomy facts. Document. Data equals, water boils at 100 degrees C at standard atmospheric pressure. Title equals, physics fundamentals. Hash use with a citation supporting LM equals DSPy. LM, Anthropic/Claude Opus 4-1-20,250,805. Predictor equals DSPy. Predict AnswerWithSources. Result equals predictor documents equals docs. Question equals, what temperature does water boil? LM equals LM. Print result, citations.
This code demonstrates DSPy's citation-enabled document handling pattern, where structured documents are processed by an LM to generate answers with traceable sources. The pattern uses a class-based signature to define the input-output contract, with document objects containing the source material and metadata, and citations capturing the references in the response. The implementation follows DSPy's modular design, where DSPy, predict, serves as the execution module that takes the signature and LM to produce the result. The AnswerWithSources signature declares the expected behavior, while the document class formats the content in a way that citation-capable LMs like Anthropic's Claude can process. This approach separates the task specification from the execution, allowing the framework to optimize prompts automatically. This pattern is particularly useful for applications requiring verifiable answers, such as research assistance or fact-checking tools. The trade-off is that it relies on LMs with citation support, limiting the choice of models. However, the modular structure means you can swap LMs or extend the signature without rewriting the core logic, making it adaptable to different use cases while maintaining citation integrity. Let's break it down.
Import DSPy.
Imports the DSPy framework, providing access to its core functionality for working with language models through declarative signatures and modules.
From DSPy, signatures import signature.
Imports the signature class from the DSPy signatures module, which provides the declarative specification for defining input-output behavior of DSPy modules.
From DSPy, experimental import document citations.
Imports the document and citations classes from DSPy's experimental module, enabling document handling and citation extraction for language model responses.
Class AnswerWithSources signature. Answer questions using provided documents with citations.
Defines a DSPy signature class named AnswerWithSources that declares a task for answering questions using provided documents with citations. The docstring specifies the expected behavior of this signature, indicating that any module using this signature should generate answers that include proper citations from the given documents. This establishes a clear contract for what the LM should accomplish when this signature is used.
Documents. List document equals DSPy, input field.
Declares an input field named Documents with a type annotation specifying it expects a list of document objects. This creates a typed input parameter for a DSPy signature, indicating the module will receive a collection of documents as input. The DSPy input field constructor marks this as an input field in the signature's declarative specification.
Question. SDR equals DSPy, input field.
Creates an input field named Question with string type annotation using DSPy's input field class. This defines a typed input parameter for a DSPy signature, where Question will accept string values when the signature is used in a module. The line establishes the field's name and data type, but doesn't specify additional metadata like descriptions or constraints.
Answer. SDR equals DSPy, output field.
Declares an output field named Answer with type annotation SDR using DSPy's output field class. This creates a typed field that will hold string output from a DSPy module, with the field name semantically indicating it represents an answer in the module's signature.
Citations. Citations equals DSPy, output field.
Creates an output field named Citations with the type Citations using DSPy's output field class. This defines a structured output that will contain citation data extracted from language model responses, including quoted text and source references.
Docs.
Initializes an empty list named Docs to store document objects for DSPy processing. This list will likely hold DSPy, document, instances containing content and metadata that can be cited by language models during citation-enabled responses.
Document.
Creates a document object in DSPy, which represents content that can be cited by language models. This document type includes both the content and metadata to help the LM understand and reference the source material, particularly useful for citation-enabled responses.
Data equals. The Earth orbits the Sun in an elliptical path.
Assigns a string value containing the factual statement, the Earth orbits the Sun in an elliptical path, to a variable named data. This creates a simple string variable that stores this specific astronomical fact for potential use in subsequent operations.
Title equals. Basic astronomy facts.
Assigns the string basic astronomy facts to a variable named title. This creates a simple string identifier that will likely be used elsewhere in the code to represent or display the title of astronomy-related content.
Data equals. Water boils at 100 degrees C at standard atmospheric pressure.
Assigns a string containing the factual statement, water boils at 100 degrees C at standard atmospheric pressure, to a variable named data. The string serves as a literal value that could be used as input or reference material in subsequent processing steps.
Title equals. Physics fundamentals.
Assigns the string value, physics fundamentals, to a variable named title. This creates a simple string identifier that will likely be used elsewhere in the code to represent or reference physics-related content.
LM equals DSPy. LM, Anthropic / Claude Opus 4-1-20,250,805.
creates a language model instance using DSPy's LM class, configured to use the Anthropic Claude Opus model version 412.02.50805. The variable LM now holds this language model object, which can be used for text generation tasks within the DSPy framework.
Predictor equals DSPy. Predict answer with sources.
Creates a predictor instance using the DSPy predict module with the AnswerWithSources signature. This sets up a DSPy module that will generate answers with source citations when invoked, following the behavior defined by the AnswerWithSources signature. The predictor is now ready to process inputs and produce outputs according to that signature specification.
Result equals predictor documents equals docs. Question equals, what temperature does water boil? LM equals LM.
Calls the predictor with 3 arguments: a collection of documents, docs, a specific question about water's boiling temperature, and a language model, LM. The operation processes these inputs to generate a result, likely leveraging the provided documents and language model to answer the question.
Print result, citations.
Prints the citations extracted from the language model response stored in the result object. The citations include quoted text and source references that the LM used to generate its response, particularly when using models that support citation extraction, like Anthropic Citations API. This implementation showcases DSPy's modular approach to citation-enabled document processing. The AnswerWithSources signature defines a clear contract for question answering with source references, using typed input-output fields that separate task specification from execution. Documents are structured with content and metadata, while the citations type captures traceable references and responses. The DSPy predict module bridges these components, processing inputs through a citation-capable LM like Claude Opus. This pattern enables verifiable answers while maintaining flexibility. You can swap LMs or extend the signature without rewriting core logic. The trade-off is reliance on citation-supporting models, but the modular structure ensures adaptability across different use cases while preserving citation integrity.
The unwritten documents whisper citations to the LM, while the question plucks answers from thin air.